Hello dear all, welcome to the another video of our course, that is Discrete Mathematics, and in this video today we are going to learn about the reflexive relations. So before explaining the definition of reflexive relation, first I am going to give you the example which helps you to understand the concept of reflexive relations. After that I am going to define what exactly the reflexive relation is. Suppose consider we have set A which contain three elements A, B and C, and this is the cross product A cross A where we A cross A where the every elements need to be ordered, and we can represent the cross product using this way. And we can also represent the cross product using the matrix representation. So this is the how we can represent the cross product using matrix. In a cross product, if we have three elements, total we have 3 into 3 elements, so that is total 9 numbers of elements we have. So if we have n numbers of elements in a set A, then we have total n into n number of elements in a cross product, and this is how we can represent the cross product using matrix. So here AA is represented in first cell, AB is represented in second cell, AC is represented in third cell, BA, BB, BC, CA, CB and CC. Here I color the diagonal elements using yellow color. So these diagonal elements are known as reflexive elements, and in any relation these all elements are there, then this type of relation is known as reflexive relation. So in reflexive relation, this diagonal element needs to be present. This all diagonals element needs to be present. So the reflexive relation on set is a binary element in which every element is related to itself. Here every element, here AA is related to itself, B is related to itself, C is related to itself. So in reflexive relation on set is a binary element in which every element is related to itself. R is said to be reflexive if AA belongs to R for all A belongs to A. That is, the every element of A is every element of A in R is related to itself. So in reflexive relation, the every element needs to relate to itself. So here I am going to give you the example where we need to find the relation which are the reflexive. So from the given relations we need to find which of the followings are reflexive relation. Consider we have set A which contain three elements, and we have R1, R2, R3 and R4 and R5. These are the 5 relations. Among these 5 relations we need to identify which are the reflexive relation. So in reflexive relations we need to include all these diagonal element, that is AA, BB, CC. So this is the diagonal elements which are related to itself. A is related to A, B is related to B, C is related to C. So we need to include all these elements in a relation so that our relation will be reflexive. So first relation R1, here we have AA. So first diagonal pair we have, and we have BB. So this is another diagonal pair, and CC. So this is another diagonal pair. So we have all the diagonals pair in R1, so that this R1 is known as reflexive relations. And in R2 we have first diagonal elements, okay. We have second diagonal elements, okay. And we have AC, but we don't have the third diagonal elements, so that we don't have all the diagonal elements, so that R2 is not a reflexive relation. So and here R3 we have AA, so BC, AC, we have BB and CC. So So this R3 is also a reflexive relation because we have these three diagonal elements, that is AA, BB and CC. So if we contain all the diagonal elements, then the relation is said to be reflexive. And R4 is A cross A. So that is A cross A which contain all these elements. So obviously this R4 is also a reflexive relation because it contains all the elements including these diagonal pairs. And R5 is the empty relation which doesn't contain any element. So that if the relation which doesn't contain any element, then this relation is not a reflexive relation. So in simple word, the reflexive relation is those relation in which the every element is related to itself, or we can also call this reflexive relation as diagonal relations where the diagonal element needs to present. So in reflexive relation we must need to include these diagonal elements. So this is all for today's lectures. So in next video we are going to see the next type of relation.